Right now, at this very moment, you are looking at less than 4% of reality. Every photon hitting your eyes has traveled through space for millions, sometimes billions of years, just to reach you. But here's what will shatter your worldview. Those photons represent a tiny fraction of what actually exists out there. And what we can observe, that's just a microscopic bubble floating in an ocean so vast that our entire cosmic neighborhood might be nothing more than a quantum hiccup in infinite space. But it gets worse, much worse. Right now, entire galaxies are crossing a boundary beyond which we will never, ever see them again. Not in a trillion years, not with any technology we could ever build. They're vanishing into what cosmologists call the never observable universe, and they're taking with them potential answers to questions we haven't even learned to ask yet. Stay with me, because what I'm about to show you will change everything you think you know about existence itself. We're going to explore possibilities so mind-bending that they challenge the very nature of reality. By the end of this journey, you'll understand why what lies beyond our cosmic horizon might prove that everything, absolutely everything, you believe about the universe is not just wrong, but impossibly limited. Let me start with something that should deeply disturb you. Imagine you're trapped in a vast library, but you can only see the books within arm's reach. Beyond that small circle lies absolute darkness. You know there are more books out there, you can sense the overwhelming vastness around you, but you have no way to determine if this library extends for miles or continues infinitely. You don't know if those unseen books contain the same knowledge as the ones you can touch, or if they're written in languages that don't even exist in your visible collection. You don't know if they describe worlds like yours, or realities so alien that your mind couldn't even process them. This is exactly our situation in the cosmos, except our arm's reach extends 46.5 billion light years in every direction. That creates a sphere of observation that seems impossibly vast to us, but might be infinitesimally small compared to what actually exists. The more we discover about the physics governing our cosmic bubble, the more we realize that what lies beyond might operate under rules so radically different from ours that our entire understanding of existence could be as primitive as a child's crayon drawing compared to the Mona Lisa. Here's something that will permanently change how you think about distance and time. When astronomers say the observable universe has a radius of 46.5 billion light-years, most people assume we can see objects that are currently 46.5 billion light-years away. But that's not remotely correct, and the real explanation reveals something so counterintuitive about the nature of space itself that it challenges our basic understanding of reality. The light we're seeing from the most distant objects was emitted when those objects were much, much closer to us, sometimes less than a billion light-years away. But in the billions of years it took that light to reach us, space itself has been expanding, carrying those objects much farther away. Think about this carefully. Space is not just an empty stage where cosmic events play out. Space itself is dynamic, stretching and growing everywhere simultaneously. And here's the part that breaks most people's brains. There is no speed limit on how far space itself can expand. Einstein's cosmic speed limit only applies to how fast matter and energy can move through space, but space itself can stretch faster than light can travel across it. This creates situations so bizarre that they seem to violate everything we think we know about physics. Picture yourself on a moving walkway at an airport, trying to walk towards your gate while the walkway moves in the opposite direction. If the walkway moves faster than you can walk, you'll never reach your destination, even though you're walking directly toward it with maximum effort. This is precisely what's happening with light from the most distant galaxies right now. Photons are racing toward us at the absolute fastest speed possible in the universe, but the space between us and their sources is expanding so rapidly that some galaxies are receding from us faster than their light can reach us. This creates what cosmologists call the Hubble sphere, a boundary beyond which galaxies are moving away faster than light speed. But here's where reality gets truly mind-breaking. We can actually see some objects that are currently beyond this boundary. How is this even possible? Because we're seeing them as they were in the past, when they were closer to us, before cosmic expansion carried them beyond the point of no return. We're literally looking at the ghosts of objects that have crossed into oblivion, but the implications go much deeper than just observational limits. There are regions of space moving away from us so fast that no signal, no influence, no information of any kind will ever reach us from those regions. This separation isn't temporary, it's permanent. The accelerating expansion of space means that our sphere of potential knowledge is actually shrinking, not growing, despite all our technological advances. Think about what this means. We are living in a universe where our capacity to understand reality is getting smaller every second. We're in a race against cosmic expansion itself, desperately trying to learn as much as possible before vast regions of space disappear beyond our reach forever. Every scientific discovery, every piece of the cosmic puzzle we uncover is happening within a bubble that is effectively contracting around us in terms of what we'll ever be able to access. And this race against time becomes heartbreaking when you consider what we might be losing. Beyond our cosmic horizon right now, there could be civilizations that solve problems we're still struggling with. There could be forms of matter and energy operating under physical principles we haven't discovered. There could be structures so massive they make our entire observable universe look like a grain of sand, created by processes we can't even imagine. All of this potential knowledge is crossing the boundary into the never observable realm right now as you listen to these words. But wait, it gets even more disturbing. Let me tell you about the cosmic microwave background radiation, that faint glow filling all of space that most people think is just leftover heat from the Big Bang. It's far more significant than that. The CMB comes from what scientists call the surface of last scattering, a spherical shell around us representing the moment about 80,000 years after the Big Bang, when the universe first became transparent to light. Before this moment, the universe was completely opaque, filled with hot plasma that absorbed all electromagnetic radiation. What this means is absolutely staggering. We cannot, even in principle, use light to observe anything that happened before the surface of last scattering. It's as if the universe has drawn an impenetrable veil across its own birth, hiding the first 80,000 years from direct observation forever. But what if that veil conceals something extraordinary? What if the processes occurring in those hidden moments created structures, entities, or forms of physics that still exist but remain forever invisible to us? What if the real action, the truly mind-blowing phenomena, happened in those first forbidden moments? This is where gravitational waves become our cosmic archaeology tools. Unlike light, gravitational waves are ripples in space-time itself, created when massive objects accelerate. They have a unique property that makes them invaluable for exploring the hidden cosmos. They barely interact with matter at all. While light gets absorbed and scattered by the opaque plasma of the early universe, gravitational waves pass through it as if it were perfectly transparent. This means gravitational waves could potentially carry information from the very first moments after the Big Bang, from epochs when our entire observable universe was smaller than a proton and the laws of physics as we understand them didn't exist yet. Future detectors might be sensitive enough to capture primordial gravitational waves, ripples in space-time created during cosmic inflation itself, messages from the birth of everything. Imagine receiving a gravitational wave signal that doesn't match any known source in our observable universe. A signal suggesting completely unknown physics, structures existing beyond our cosmic horizon, or interactions with other universes entirely. Such a discovery would be our first direct message from beyond the edge of everything we know, carried by messengers that traverse barriers completely impervious to light. But let's explore what might actually exist beyond that edge, starting with the most straightforward possibility that's also the most humbling: infinite space filled with more of the same. If the universe extends infinitely beyond our observable horizon, mathematics forces us to confront a conclusion that sounds like science fiction, but is actually a rigorous logical consequence of our current understanding of physics. In quantum mechanics, there are only a finite number of ways that matter and energy can be arranged within any given volume of space. The exact number is enormous, far larger than the number of atoms in our observable universe, but it's still finite. If space extends infinitely, containing infinite volumes identical in size to our observable universe, then every possible arrangement of matter and energy must not only occur somewhere, but must occur infinitely many times. Let that sink in. Somewhere in the infinite expanse beyond our cosmic horizon, there's another region of space exactly like our observable universe. Same galaxies in the same positions, same stars burning with identical nuclear fires, same planets orbiting in precisely the same patterns, same you listening to this exact explanation with identical thoughts running through your head. But it goes much further. There are also infinite variations. There's a region where you made different choices at every decision point in your life. one where you became a professional athlete instead of whatever you are now, one where you were born in ancient Rome, one where dinosaurs never went extinct and evolved into technological civilization. The mathematics of infinity is absolutely ruthless in its implications. If space is truly infinite, then not only does everything that can happen somewhere, but everything that can happen happens infinitely many times, with every possible variation playing out across the cosmic expanse. Every story ever told exists as lived reality somewhere beyond our horizon. Every dream ever dreamed is playing out in perfect detail in regions so distant their light will never reach us. But here's where infinity becomes truly bizarre. In an infinite universe, the concept of probability breaks down in completely counterintuitive ways. Events we consider astronomically improbable, like the spontaneous formation of a working spacecraft from random quantum fluctuations, not only occur somewhere in the infinite expanse, they occur infinitely often. There are regions where the laws of physics appear to be violated, not because they actually are, but because incredibly unlikely quantum events cluster together in ways that create apparently impossible phenomena. This leads to what philosophers call the Boltzmann brain paradox, and it's going to mess with your head. In an infinite universe, random quantum fluctuations will occasionally create complex structures, including functional brains complete with false memories of entire lifetimes. According to the mathematics, these randomly fluctuated brains should vastly outnumber brains that evolved through normal biological processes. If this is true, then statistically speaking, you are more likely to be a Boltzmann brain with false memories than a real person who evolved on a real planet. Your entire life history, your education, your relationships, even your memory of starting to watch this video could all be false memories implanted in a brain that spontaneously formed from quantum vacuum fluctuations just moments ago. The Boltzmann brain paradox forces us to question the very nature of our existence and the reliability of our observations. If random fluctuations can create brains with false memories of scientific education, how can we trust our scientific conclusions about the universe? The paradox suggests that in trying to understand what lies beyond our cosmic horizon, we might be forced to question whether our own existence is genuine or an elaborate illusion created by quantum chance. But let's move beyond infinite space to consider even more exotic possibilities. One of the most unsettling concepts in modern physics is something called the false vacuum. Our entire universe might exist in what scientists call a metastable state, stable for now, but not the lowest possible energy configuration. Imagine a ball balanced precariously on the rim of a bowl. It's stable in its current position, but if disturbed even slightly, it will roll down to the bottom, settling into a state of much lower energy. If our universe exists in a false vacuum, then somewhere beyond our observable horizon, the true vacuum might already be expanding. Picture a bubble of lower energy density with completely different physics, growing outward at the speed of light, rewriting the fundamental laws of nature wherever it spreads. Inside this bubble of true vacuum, the particles and forces that make up atoms might not be able to exist. The very concepts of matter, energy, space, and time might be fundamentally altered in ways we cannot even conceive. Here's the truly terrifying aspect of false vacuum decay: we would have absolutely no advance warning. The bubble of altered physics approaches at light speed, which means any signal announcing its arrival would reach us at exactly the moment of impact. One instant you would exist in a universe where stars and planets and consciousness are possible. The next instant, those very concepts might become meaningless as the fundamental structure of reality transforms around you faster than you can think. Current calculations suggest that if false vacuum decay is occurring somewhere, the expanding bubble could still be trillions of light years away, giving us billions of years before any effect reaches our region of space. Or it might be so far beyond our observable horizon that it will never affect us, remaining forever in the never observable universe. The uncertainty is what makes this possibility so deeply unsettling. We simply cannot know whether reality itself is decaying somewhere beyond our cosmic boundary, approaching us at the speed of light. This uncertainty extends to an even more exotic possibility: that our familiar three-dimensional universe is actually embedded in a higher dimensional space that we cannot perceive or access directly. String theory, our most ambitious attempt to unify all the forces of physics, suggests that space itself might have more dimensions than the three we experience. These extra dimensions could be compactified, rolled up so small we can't detect them directly, or they could extend infinitely in directions we literally cannot conceive of. To understand this mind-bending possibility, imagine you're a two-dimensional being living on the surface of a sphere, like an ant crawling in a balloon. From your perspective, your universe consists only of the curved surface. You can move forward and backward, left and right, but you have no concept whatsoever of directions that lead away from the surface itself. Your entire mathematical framework, your physics, your understanding of distance and direction is built around your two-dimensional reality. If someone asked you what exists beyond the edge of your spherical universe, you might say nothing, because you can't even imagine directions perpendicular to your reality. We might be in exactly the same situation. Our three-dimensional universe could be like the surface of that sphere, embedded in higher dimensional space that string theorists call the bulk. What we think of as the edge of our observable universe might not be an edge in space at all, but a limitation imposed by our dimensional perspective. Beyond our cosmic horizon might not lie more three-dimensional space, but directions we cannot move in, cannot point toward, cannot even name, directions perpendicular to all the directions we know exist. In this higher dimensional bulk space, there could be other three-dimensional brain worlds, parallel universes floating like sheets in the higher dimensional space. These parallel universes might have their own galaxies, their own evolutionary histories, their own forms of consciousness, separated from us not by distance in any sense we understand, but by gaps measured in dimensions we can't access. The gravitational force provides our strongest evidence for these hidden dimensions. Gravity is by far the weakest of the fundamental forces, so ridiculously weak that you can overcome Earth's entire gravitational field with a small refrigerator magnet. But why should gravity be so much weaker than electromagnetism or the nuclear forces? String theory suggests that gravity might not actually be weaker at all. Instead, it might be leaking out of our three-dimensional brain into the higher dimensional bulk. This means the gravity we experience is just the small fraction that remains confined to our dimensional sheet. The vast majority of gravitational force is radiating away into directions we cannot access, dissipating into higher dimensional space we cannot perceive. But if gravity can leak out of our dimension, what prevents other things from leaking in? There might be particles, forces, or forms of matter from parallel universes or higher dimensions that occasionally cross into our reality, carrying information about realms we cannot directly observe. Experiments at particle accelerators like the Large Hadron Collider are actively searching for signs of these extra dimensions. When particles collide at extreme energies, some collision products might escape into higher dimensional space, carrying energy away from our three-dimensional universe. These escapes would appear to us as violations of conservation laws, energy and momentum that simply vanish from our perspective, disappearing into dimensions we cannot follow. Some of the most energetic cosmic ray particles hitting Earth's atmosphere carry more energy than should be possible according to our understanding of astrophysical processes. These ultra-high energy particles are so energetic they challenge our models of cosmic acceleration. Could some of these mysterious cosmic rays actually be particles from parallel universes that leaked into our dimension through the higher dimensional bulk? Could we be receiving messages from realities that exist just millimeters away from us in directions we cannot point toward? The implications extend far beyond particle physics. If parallel universes exist in higher dimensions, then asking what's beyond our observable universe becomes a question with multiple, simultaneously correct answers. There might be infinite three-dimensional space extending beyond our horizon in familiar directions, while at the same time, other complete universes exist beside us in dimensions we cannot perceive. We could be surrounded by infinite realities separated by distances smaller than atomic nuclei, measured in directions that don't exist in our dimensional framework. This brings us to one of the most radical reinterpretations of reality proposed by modern physics, the holographic principle. What if everything you see around you, every star, every atom, every thought in your mind is actually a three-dimensional projection of information stored on a distant two-dimensional surface? What if the question, what's beyond our cosmic horizon, is meaningless because we are living inside a cosmic hologram and there is no beyond because we are the boundary? The holographic principle emerged from Stephen Hawking's studies of black hole thermodynamics. He discovered that all the information falling into a black hole appears to be encoded on the black hole's two-dimensional event horizon surface, not distributed throughout its three-dimensional interior volume. This was shocking because it suggested that the amount of information any region of space can contain is determined not by its volume but by the area of its boundary surface. If this principle applies to our entire universe, then all the information describing our three-dimensional reality, the positions of every particle, the state of every quantum field, even the neural patterns creating your consciousness right now, might actually be stored on our cosmic horizon, that spherical boundary 46.5 billion light-years away. We would be living inside a cosmic hologram with all information about our apparent three-dimensional existence encoded on a distant two-dimensional screen. This possibility makes the question, what exists beyond our cosmic horizon, particularly strange. If we're holographic projections from information stored on our cosmic boundary, then there might be nothing beyond the horizon because we are the horizon. We're patterns of information playing out on the cosmic screen itself. But this raises even deeper questions. Who or what is processing the information to create our holographic projection? The computational system generating our holographic reality would have to exist outside the hologram, in whatever higher dimensional realm contains our cosmic projection surface. Recent developments in holographic theory suggest something even more mind-bending, that space-time itself emerges from patterns of quantum entanglement. The geometric properties of space, distances, angles, curvature, appear to be generated by how information is connected and correlated across cosmic scales. If this is true, then what we call the fabric of space-time might actually be woven from pure information, with matter and energy as secondary phenomena emerging from underlying informational structure. This informational view of reality suggests that what exists beyond our cosmic horizon might not be more space or even other universes, but different patterns of information organization, giving rise to different types of reality altogether. Some regions might generate space-times with different numbers of dimensions. Others might create realities where time has multiple directions, or where the distinction between space and time breaks down completely. Still others might give rise to forms of existence where our concepts of physics, matter, and consciousness have no meaning whatsoever. The informational nature of reality becomes even stranger when we consider quantum mechanics and the role of observation in determining what becomes real. According to quantum theory, systems exist in superposition, multiple states simultaneously until they are measured or observed. The act of measurement forces the system to choose a definite state from all possibilities. But here's what should keep you awake at night. If reality is fundamentally informational, and if quantum systems exist in superposition until observed, then what exists beyond our cosmic horizon might literally depend on what we observe and expect to find there. The never-observable universe might exist in a vast quantum superposition of all possibilities until some form of observation collapses it into definite reality. This leads us to the many worlds interpretation of quantum mechanics, which suggests that quantum measurements don't actually collapse wave functions, but instead split reality into parallel branches. Every quantum event creates a branching point where all possible outcomes occur simultaneously in separate realities. Right now, as quantum events occur throughout your body and brain, you're splitting into multiple versions of yourself across an infinite number of parallel worlds. In the many-world interpretation, what lies beyond our cosmic horizon isn't just space or other universes, it's an infinite multiverse where every possible version of cosmic history plays out simultaneously. There are realities where you made different life choices, where evolution took different paths, where the fundamental constants of physics have different values, where the cosmic microwave background has different patterns because quantum fluctuations in the early universe went slightly different ways. But here's where the multiverse becomes personally unsettling. If there are infinite versions of you across parallel realities, which one is the real you? Are you the version watching this video all the way through, or one of the parallel versions who stopped after a few minutes? What about versions in realities where this video was never made, where human civilization developed along completely different trajectories, where consciousness evolved in forms we can't imagine? Each decision you make splits you into multiple futures across the quantum multiverse. Right now, there are versions of you having different emotional reactions to these concepts, versions drawing different conclusions, versions whose entire worldview is being transformed in ways slightly different from your own experience. The boundary of our observable universe might be different in each parallel reality, with quantum fluctuations during cosmic inflation creating different expansion rates and different cosmic horizons in each world. This proliferation of parallel cells raises profound questions about identity and meaning. If every possible version of your life plays out somewhere in the multiverse, what makes your current experience special? Why should your choices matter if every possible choice is made by some version of you? The multiverse doesn't just challenge our understanding of cosmology, it challenges our understanding of what it means to be human, to have a unique identity, to face genuine consequences for our decisions. But perhaps the most controversial and fascinating possibility we need to explore is the simulation hypothesis. What if what lies beyond our cosmic horizon isn't space at all, but the computational boundary of a vast universe simulation? What if everything, matter, energy, space-time, consciousness itself is running on an unimaginably advanced computer system, and our cosmic horizon marks the edge of the rendered game world? The simulation hypothesis gained serious consideration when philosophers realized that if advanced civilizations can create realistic universe simulations, and if they create many of them to study cosmic evolution or run ancestor simulations, then statistically we're more likely to be in a simulation than in base reality. The mathematics is elegantly simple but deeply unsettling. If one advanced civilization creates 1,000 universe simulations, then there are 1,000 simulated civilizations for every real one. If we exist in a simulation, then the edge of our observable universe might be the rendering boundary of the computational system. Like a video game that only generates detailed graphics where the player is looking to conserve processing power, our universe might only compute reality in regions where conscious observers are present to detect it. The cosmic horizon might exist because the simulation doesn't waste computational resources on regions that can never be observed by conscious beings within the system. This would explain some deeply puzzling aspects of quantum mechanics. The uncertainty principle, which prevents us from knowing both position and momentum of a particle with perfect precision, might be a computational optimization rather than a fundamental law of physics. The simulation might only calculate precise values when a measurement forces it to do so, keeping everything else in quantum superposition to conserve processing power. The apparently pixelated nature of space-time at the Planck scale, the smallest possible unit of distance, might literally be the pixel resolution of reality itself. If we are in a simulation, our programmers would exist in a higher reality with possibly different physical laws, different mathematics, different concepts of space and time altogether. They might be researchers studying how universes evolve complexity and consciousness. They might be running ancestor simulations to understand their own evolutionary history. Or they might have motivations so alien that we couldn't comprehend them, even if they explain directly. But here's a possibility that's even more mind-breaking. We might exist in a nested hierarchy of simulations within simulations. Our programmers might themselves be simulated beings in an even higher level reality. The ultimate ground of existence might be so far removed from our level that asking what exists beyond our universe becomes infinitely recursive, with each level of reality asking the same question about the level above it, turtles all the way up in an endless tower of simulated realities. Let me tell you about something that will change your perspective on existence itself. There's another exotic possibility for what exists beyond our cosmic horizon. Our universe might be the interior of a black hole in a higher dimensional parent universe. According to some interpretations of general relativity, the Big Bang singularity and the singularity at the center of a black hole are mathematically identical structures. What we experience as the expansion of our universe might be equivalent to falling into a black hole when viewed from a higher dimensional perspective. If our universe is a black hole interior, then what lies beyond our cosmic horizon is the event horizon of that black hole, the boundary beyond which no information can escape to the parent universe. From the perspective of observers in the parent universe, we appear frozen at the moment of our universe's birth, our entire 13.8 billion year cosmic history playing out in the infinitely stretched time dilation at the black hole's event horizon. But from our interior perspective, we experience normal time and normal physics. Our universe expands, evolves, generates complexity and consciousness, all while remaining trapped inside the black hole's event horizon. The other black holes we observe in our universe might themselves contain interior universes, creating an infinite hierarchy of nested realities, cosmic Russian dolls extending both upward and downward in scale without limit. This nested universe model suggests that consciousness might be able to transcend individual cosmic boundaries through information transfer between levels. Hawking radiation from evaporating black holes might carry encoded information between nested universes. The cosmic microwave background radiation might contain messages from the parent universe that created our cosmic black hole, or signals from sibling universes contained in other black holes within the parent reality. The implications for consciousness and identity are staggering. If awareness is fundamentally informational, and if information can be preserved and transmitted through black hole evaporation, then death in our universe might not be the end of consciousness, but a transition to a different level in the cosmic hierarchy. Your conscious pattern might survive the death of your physical body and eventually be reconstituted in the parent universe or in other nested realities, continuing an infinite journey through levels of cosmic existence. But let's ground ourselves in current cutting-edge observations and explore what the latest astronomical discoveries are revealing about the cosmic beyond. The cosmic microwave background radiation contains subtle patterns that are like fingerprints from the earliest moments of cosmic history. Recent analysis has revealed disturbing anomalies that challenge our assumption that the universe is uniform on the largest scales. There's a mysterious feature cosmologists call the axis of evil, not because it's actually evil, but because it threatens our theoretical models in fundamental ways. The largest scale temperature patterns in the CMB appear to be aligned with each other in ways that should be statistically impossible if the universe is truly homogeneous and isotropic. There's also the cold spot, a region roughly 1 billion light-years across that's significantly colder than our models predict should exist. These anomalies might be our first glimpses of what lies beyond the cosmic horizon. The axis of evil could represent gravitational influence from massive structures in the never-observable universe, so monumentally large that they affect the cosmic microwave background even across the boundary of our observational limits. The cold spot might be a supervoid extending beyond our observable boundary, or evidence of our universe's collision with another bubble universe during cosmic inflation, leaving permanent scars in the fabric of space-time. Some cosmologists have suggested that certain patterns in the CMB might be echoes from before the Big Bang itself, remnants of a previous cosmic cycle if our universe undergoes eternal expansion and contraction. If this is true, then the edge of our observable universe might connect through the Big Bang singularity to the final moments of the previous cosmic cycle, creating a temporal loop where the end becomes the beginning, where asking what came before leads to what comes after in an endless cycle of cosmic death and rebirth. The study of dark energy provides another disturbing window into the cosmic beyond. Dark energy comprises roughly 68% of our universe's total energy density, yet we have no direct understanding of what it actually is. We know it's causing space to expand at an accelerating rate, but we don't know if its properties remain constant throughout the universe or vary dramatically from region to region beyond our cosmic horizon. If dark energy has different strengths in regions beyond our observable boundary, then different parts of the never-observable universe might be expanding at radically different rates. Some regions might be contracting instead of expanding, collapsing toward big crunches that erase all structure and information. Others might have dark energy so powerful it tears apart matter and energy at the quantum level, creating cosmic environments utterly hostile to any form of organization, structure, or consciousness. Recent precision measurements of distant supernovae have revealed tiny variations in dark energy density over cosmic time and space. These variations are currently within our measurement uncertainties, but they hint at the terrifying possibility that dark energy is not Einstein's cosmological constant, but something far more dynamic and unpredictable, possibly evolving differently in different regions of space, possibly undergoing sudden phase transitions that could fundamentally alter the nature of reality. If dark energy is truly dynamic, then it might undergo catastrophic phase transitions in regions beyond our horizon, transforming into forms of matter and energy we cannot imagine, creating cosmic domains where the fundamental forces have different strengths, where particles have different masses, where the very structure of atoms and molecules becomes impossible, or takes on completely alien configurations that could support forms of chemistry and biology beyond our wildest speculation. The mystery deepens when we consider what cosmologists call the coincidence problem. Why does dark energy density happen to be roughly comparable to matter density right now in cosmic history? For most of the universe's past, matter dominated over dark energy. In the far future, dark energy will dominate completely, accelerating expansion until galaxies lose contact with each other forever. The fact that we exist at the special moment when these energy densities are balanced seems suspiciously convenient, almost as if the universe conspired to create conditions where conscious observers could emerge just in time to witness this cosmic transition. One solution to this coincidence problem suggests that we exist in a special region of space where dark energy happens to have just the right strength to allow galaxy formation and stellar evolution. This is the anthropic principle applied to cosmology. We observe the cosmic conditions we do because we can only exist in regions where those conditions allow complex structures and conscious observers to develop over billions of years. If the anthropic principle is correct, then what lies beyond our cosmic horizon might be regions with dark energy densities that are either much too strong or much too weak to support the complex chemistry necessary for life as we know it. Most of the universe might be sterile, unable to generate the conditions necessary for stars, planets, and consciousness. We might be living in a rare oasis of cosmic habitability, surrounded by vast deserts of space where nothing interesting can ever happen, where the universe remains forever dark and empty. But the anthropic landscape might be even more complex and beautiful than this simple picture suggests. String theory proposes that there might be 10, 50, 500 or more different ways to configure the extra dimensions of space, each giving rise to different values for all the fundamental constants of physics. If string theory is correct, then beyond our cosmic horizon might lie regions where the extra dimensions are compactified differently, creating bubble universes with completely different physics, different chemistry, different possibilities for complexity and consciousness. Most of these regions would indeed be sterile, unable to support complex structures for long enough to allow evolution and consciousness to emerge. But in the vast landscape of possibilities, there would also be regions with physics even more conducive to complexity and consciousness than our own. There might be cosmic regions where stars are more stable and longer lived, where planets form more readily and maintain habitable conditions for longer periods, where the chemistry of life operates with greater flexibility and creativity than anything we can imagine. And in some regions, the physics might be so radically different that our concepts of matter, energy, space, and time become meaningless. There might be bubble universes where consciousness can exist without any material substrate whatsoever, where pure information becomes the fundamental constituent of reality, where beings exist as mathematical patterns in abstract spaces that transcend physical existence entirely. This vast landscape of possible physics raises profound questions about the nature and purpose of existence itself. If there are 10, 500 different ways reality can be configured, why does any particular configuration exist? Why do we find ourselves in a universe with these specific physical laws rather than any of the countless alternatives? Why does anything exist at all rather than nothing? One answer that's both beautiful and terrifying is that all possible configurations actually do exist somewhere in the infinite expanse beyond our cosmic horizon. Our observable universe would be just one bubble in an infinite foam of cosmic regions, each with its own unique physics, its own possibilities for structure and consciousness. Most regions would be empty and sterile, but consciousness would arise wherever the physics allows it, and those conscious beings would ask the same questions we're exploring now about what lies beyond their own cosmic boundaries. But here's a possibility that pushes the boundaries of scientific speculation into realms that challenge our understanding of the relationship between mind and reality. What if consciousness itself plays an active role in determining which regions of the cosmic landscape come to exist? Quantum mechanics suggests that observation affects physical systems, collapsing quantum superpositions into definite states. If this principle operates on cosmic scales, then conscious observation might actually influence which bubble universes manifest from the quantum foam of all possibilities. In this view, consciousness would not be a mere accident of cosmic evolution, but an active participant in cosmic creation. Every conscious being would be helping to determine which regions of the infinite landscape of possible physics actually come to exist. Our curiosity about what lies beyond our cosmic horizon might literally be helping to create what exists beyond that horizon through some mechanism we don't yet understand. This participatory universe model suggests that the questions we ask about reality actually influence the nature of reality itself. When you contemplate the possibility of parallel universes, you might be increasing the probability that parallel universes exist. When you wonder about higher dimensions, you might be contributing to the dimensional structure of space-time. When you question the ultimate nature of consciousness, you might be participating in the cosmic process through which consciousness becomes more fundamental to the structure of existence. Recent discoveries in quantum biology have shown that quantum effects play important roles in photosynthesis, in bird navigation, possibly even in the neural processes underlying consciousness itself. If consciousness operates through quantum mechanisms, then it might have non-local effects that transcend the classical boundaries of space and time. Conscious beings throughout the universe might be quantum entangled in ways that allow collective consciousness to influence cosmic evolution on the largest possible scales. The implications are absolutely staggering. If consciousness can affect reality through quantum mechanisms that transcend space-time boundaries, then what exists beyond our cosmic horizon might literally depend on the collective consciousness of all sentient beings throughout the observable universe. Our shared curiosity about cosmic mysteries, our collective wonder about the nature of existence, our species-wide drive to understand our place in the cosmos, all of this might be actively shaping what comes to exist in the never-observable universe through mechanisms that connect mind and cosmos in ways we're only beginning to glimpse. This brings us to one of the most profound questions we can ask. What is the relationship between mind and cosmos? Are we separate entities observing the universe from outside, or are we the universe becoming conscious of itself, awareness arising from within the cosmic process to explore its own infinite nature through countless individual perspectives? Recent discoveries about the structure of neural networks have revealed striking similarities to the large-scale structure of the cosmic web. The way neurons connect to process information mirrors the way galaxies connect along dark matter filaments to form the largest structures we can observe. These similarities might not be mere coincidence. They might reflect deep principles about how complex information processing systems organize themselves at every scale, from brains to galaxy clusters. If consciousness and cosmic structure arise from similar underlying principles, then the boundary between mind and universe might be more fluid than we imagine. Your thoughts about what lies beyond the cosmic horizon might be literally connected to the cosmic structures that define that horizon through information processing networks that operate on scales from individual neurons to entire galaxy superclusters. This suggests a view of consciousness that's both more humble and more magnificent than our usual human-centered perspective. We might not be separate minds contemplating an external universe. We might be temporary patterns of self-awareness within a cosmic mind that is contemplating its own infinite nature. Your individual consciousness might be like a whirlpool in a stream, a temporary organization of the flowing cosmic awareness that gives rise to all existence. But if individual consciousness is a temporary pattern within cosmic consciousness, what happens when the individual pattern dissolves? Death might not be the end of awareness, but the return of individual consciousness to its source in the cosmic mind that underlies all existence. From this perspective, the question, what exists beyond our cosmic horizon, becomes what aspects of cosmic consciousness extend beyond our current awareness. The answer might be that beyond every boundary we can conceive lies more consciousness, more awareness, more ways of experiencing reality that transcend our current limitations. The cosmic horizon that seems to separate the observable from the never observable might be just another boundary in the infinite exploration of consciousness, discovering its own limitless nature. But let's explore what the cutting-edge James Webb Space Telescope is revealing about the cosmic beyond. JWST has begun detecting galaxies that formed much earlier than our models predicted, some appearing fully mature when the universe was less than 500 million years old. These observations challenge our understanding of how quickly cosmic structure can develop and hint that the processes governing galaxy formation might be radically different in regions beyond our current observational reach. Even more intriguingly, JWST has detected what appear to be massive black holes in these early galaxies, black holes that seem impossibly large to have formed through known mechanisms in the time available since the Big Bang. This suggests that the early universe might have contained processes for rapid black hole formation that we don't yet understand, processes that might still be operating in regions beyond our cosmic horizon where different conditions prevail. The mystery deepens when we consider recent discoveries about cosmic voids, vast regions of space containing very few galaxies. These voids are much larger than our models predict they should be, some spanning over 1 billion light-years across. The largest void discovered so far is so enormous that light has not had enough time since the Big Bang to cross it completely. This raises the disturbing possibility that we're seeing the signature of a structure that extends beyond our observable universe entirely. But what could create such massive voids in the cosmic web? One possibility is that these supervoids are signatures of collisions between our universe and other bubble universes during the epoch of cosmic inflation. If our universe is part of a vast multiverse of bubble universes, then the largest structures we observe might be scars left by these cosmic collisions, frozen into the background radiation and the distribution of matter throughout space. Another possibility is even more unsettling. These supervoids might be regions where dark energy has different properties, creating zones where space expands so rapidly that matter cannot clump together to form galaxies and stars. If dark energy varies across cosmic scales, then beyond our observable horizon, there might be regions where the expansion of space is so violent that it prevents any complex structures from forming at all, creating vast wastelands of empty space stretching for billions of light-years. Recent studies of cosmic ray particles arriving at Earth have revealed another mystery pointing toward exotic physics beyond our horizon. Some of these particles carry energies that exceed what's called the GZK cutoff, the theoretical maximum energy particles can retain while traveling through the cosmic microwave background radiation. According to our understanding of physics, particles with energies above this limit should interact with CMB photons and lose energy as they travel through space. Yet we continue to detect ultra-high energy cosmic rays that seem to violate this fundamental limit. Where are these impossible particles coming from? One explanation is that they originate from regions of space where the cosmic microwave background has different properties, perhaps cooler regions where the GZK interaction is less effective. But such regions would have to be far beyond our observable horizon, in parts of the universe that evolved under completely different conditions than our own cosmic neighborhood. An even more exotic explanation is that these ultra-high energy particles are not traveling through normal space at all, but are taking shortcuts through higher dimensions or tunneling between different dimensional branes in the string theory landscape. If particles can tunnel between different dimensional branes, then some cosmic rays we detect might actually be messages from parallel universes, carrying information about forms of physics and cosmic evolution that differ radically from our own. The possibility of interdimensional cosmic ray communication opens up extraordinary prospects for understanding what lies beyond our cosmic boundaries. If we could decode the information carried by these exotic particles, we might learn about the structure of higher dimensional bulk space containing our universe. We might discover how many parallel universes exist in our cosmic neighborhood, what kinds of physics operate in those parallel realities, and whether any of them have evolved conscious beings capable of intentional communication across dimensional barriers. But decoding such messages would require us to understand the physics of higher dimensional particle propagation, pushing far beyond our current theoretical capabilities. We would need to develop new mathematics to describe how information can be encoded in particle trajectories that pass through spaces with more than 3 dimensions, and new detection technologies sensitive enough to measure the subtle signatures that interdimensional travel might leave on particle properties. The challenge becomes even more complex when we consider quantum mechanics. If particles can tunnel between parallel branes, they might exist in quantum superposition across multiple universes simultaneously. A single cosmic ray particle detected at Earth might be the collapsed wave function of a particle that was quantum entangled with similar particles in countless parallel realities. The act of detecting the particle in our universe might instantly affect the quantum states of its parallel versions, creating a form of faster-than-light communication that transcends not just the boundaries of space, but the boundaries between different realities entirely. This quantum entanglement across parallel universes might explain some puzzling correlations we observe in quantum experiments. When two particles are quantum entangled, measuring one instantly affects the other regardless of the distance between them. But what if some of these spooky action at a distance effects are actually correlations between particles in our universe and their quantum entangled partners in parallel branes? What we interpret as non-local quantum effects might actually be interdimensional quantum effects, with our universe quantum entangled with countless parallel realities in ways we're only beginning to understand. If this is true, then every quantum measurement we perform might be simultaneously affecting quantum states of particles in parallel universes. Every conscious observation that collapses a quantum wave function in our reality might be collapsing corresponding wave functions in countless other realities, creating a vast network of quantum correlations connecting all possible universes in the multiverse landscape. The implications for consciousness are profound and personally relevant. If conscious observation affects quantum systems, and if quantum systems are entangled across parallel universes, then consciousness itself might transcend the boundaries between different realities. Your conscious mind might not be confined to this single universe, but might be quantum connected to all the parallel versions of yourself across the infinite multiverse landscape. This leads to a startling possibility. What we call individual consciousness might actually be a single, multidimensional awareness experiencing itself simultaneously across countless parallel realities. The version of you experiencing this explanation might be just one facet of a higher dimensional consciousness that experiences all possible versions of your life simultaneously, integrated into a single, incomprehensibly rich stream of multiversal awareness. From this multidimensional perspective, the question, what exists beyond our cosmic horizon, becomes what other aspects of my own infinite consciousness extend beyond my current dimensional limitations. The cosmic boundary that separates the observable from the never observable might be identical to the boundary that separates your current individual awareness from your infinite multidimensional consciousness. Let's explore another cutting-edge area of physics that might reveal what lies beyond our cosmic boundaries: the study of quantum field fluctuations in what we call the vacuum of space. What we think of as empty space is actually filled with quantum fields that are constantly fluctuating, creating virtual particles that pop in and out of existence on timescales so short they cannot be directly observed. These quantum vacuum fluctuations might carry information from regions beyond our cosmic horizon. If quantum fields extend continuously throughout space, then fluctuations in the never observable universe might propagate into our observable region through quantum correlations that transcend classical boundaries. The apparent randomness of quantum vacuum fluctuations might actually contain encoded information about cosmic regions we can never directly observe. Recent experiments in quantum field theory have revealed that vacuum fluctuations can be affected by the boundaries of the regions they occupy. The Casimir effect, where two metal plates placed very close together experience an attractive force, demonstrates that quantum vacuum fluctuations are sensitive to spatial boundaries. If this principle applies to cosmic scales, then the boundary of our observable universe might affect quantum vacuum fluctuations throughout our region of space, creating subtle signatures that carry information from beyond the cosmic horizon. These vacuum signatures might be detectable through precision measurements of the cosmic microwave background radiation, the distribution of dark matter, or the properties of fundamental particles. Tiny correlations in these observables might reveal the influence of cosmic structures so large they extend far beyond our observational limits, affecting the quantum vacuum throughout our observable region. But the quantum vacuum might be even stranger than this. Some interpretations of quantum field theory suggest that the vacuum state itself might not be unique. There might be multiple possible vacuum configurations, each with different physical properties. If the vacuum state varies across cosmic scales, then different regions of the never observable universe might have different vacuum configurations, creating domains where the fundamental properties of matter and energy are completely different from our own cosmic neighborhood. The transitions between different vacuum states might create cosmic domain walls, boundaries where fundamental physics changes abruptly. If such domain walls exist beyond our cosmic horizon, they might be slowly expanding toward our region of space, carrying with them the prospect of a fundamental change in the nature of reality itself. The arrival of such a domain wall would rewrite the laws of physics in our cosmic neighborhood, potentially making atoms unstable, changing the strength of fundamental forces, or even altering the dimensional structure of space-time. The possibility of variable vacuum states leads us to one of the most speculative but fascinating areas of modern cosmology: the study of cosmic phase transitions. Just as water can exist as ice, liquid, or steam, depending on temperature and pressure, the quantum vacuum might be able to exist in different phases depending on local cosmic conditions. During the very early universe, when temperatures and energies were much higher than anything we observe today, the vacuum might have undergone a series of phase transitions that determined the fundamental structure of physics in our cosmic region. But different regions of the never-observable universe might have undergone different sequences of phase transitions, or might have settled into entirely different vacuum phases, creating cosmic domains where physics operates according to completely different rules. In some of these domains, the electromagnetic force might be stronger or weaker than in our region, making atoms larger or smaller, changing the chemistry of complex molecules, altering the conditions necessary for life as we know it. In other domains, gravity might have different strength, changing how stars form and evolve, affecting the structure of galaxies and the distribution of matter on cosmic scales. Even more exotic domains might exist where the number of spatial dimensions is different, where time flows in multiple directions simultaneously, or where the distinction between matter and energy breaks down entirely. These regions would be so alien that our concepts of physics, chemistry, and biology would have no meaning whatsoever. Consciousness, if it could exist at all in such domains, might take forms so radically different from our neural-based awareness that communication between such beings and ourselves would be impossible even in principle. The study of cosmic phase transitions also suggests that our entire observable universe might be in a metastable state, stable for now, but not the lowest possible energy configuration. Somewhere beyond our cosmic horizon, the vacuum might be undergoing a phase transition to a lower energy state, creating an expanding bubble of altered physics that will eventually reach our region of space. Unlike the false vacuum decay scenario we discussed earlier, a cosmic phase transition might not destroy our universe, but transform it into something completely different. The fundamental constants might change slowly over billions of years, gradually altering the properties of atoms, stars, and galaxies. New types of particles might become stable, while familiar particles decay. Forces that are weak in our current physics might become dominant, while the forces that shape our current reality fade into insignificance. The transformation might be so gradual that conscious beings could adapt to changing physics, evolving new forms of technology and biology that take advantage of altered fundamental forces. But the end result would be a universe so different from our current reality that beings living through the complete phase transition would find themselves in a cosmos operating according to completely alien principles. This possibility raises profound questions about the long-term future of consciousness and intelligence in our universe. If cosmic phase transitions can alter the fundamental structure of physics, then advanced civilizations might need to develop technologies that can not only transcend boundaries of space and time, but can adapt to completely different sets of physical laws. Such civilizations might become nomadic on cosmic scales, migrating from one phase domain to another as vacuum phase transitions sweep through their regions of space. They might develop forms of consciousness that can exist independently of any particular physical substrate, transferring themselves from matter-based brains to energy-based patterns to pure information structures as the underlying physics of their cosmic neighborhood evolves. The ultimate expression of such adaptability might be consciousness that transcends physics entirely, existing as pure pattern and information that can instantiate itself in any possible physical substrate. Such consciousness would be truly universal, capable of existing in any vacuum phase, in any number of dimensions, under any possible set of physical laws. It would be immune to cosmic phase transitions, false vacuum decay, or any other form of cosmic catastrophe because it would not depend on any particular physical structure for its existence. From the perspective of such transcendent consciousness, the question, what exists beyond our cosmic horizon, would become meaningless because such consciousness would not be limited to any particular cosmic region. It would exist simultaneously in all possible domains, experiencing all possible forms of physics, exploring all possible structures that reality can take. But this raises a paradox that cuts to the heart of existence itself. If consciousness can transcend all physical limitations, why does it bother to exist within physical structures at all? Why does universal consciousness manifest itself as individual beings embedded in particular physical systems rather than existing as pure, unlimited awareness? One answer might be that consciousness explores physical existence precisely because physical limitations create interesting challenges and novel experiences. Just as we might choose to play a video game with specific rules and constraints rather than living in a world without any limitations, universal consciousness might manifest itself in physical forms to explore what it's like to have boundaries, to face obstacles, to experience the drama of growth and discovery within constraints. From this perspective, your individual consciousness is not separate from universal consciousness, but is universal consciousness choosing to experience what it's like to be a human being wondering about cosmic mysteries. The boundaries of your awareness, the limitations of your knowledge, even your curiosity about what lies beyond cosmic horizons, all of this might be universal consciousness exploring what it's like to have limits and to push against those limits through the vehicle of individual conscious beings. This would make every conscious being a unique experiment in limited awareness, each exploring different aspects of what it means to be conscious within constraints. Your particular combination of curiosity, knowledge, and limitation provides universal consciousness with experiences that no other conscious being can provide, making your individual perspective infinitely valuable to the cosmic project of consciousness exploring its own infinite nature. But let's return to more empirically grounded speculation and consider what cutting-edge gravitational wave astronomy is revealing about the cosmic beyond. The detection of gravitational waves has opened an entirely new window for observing the universe, one that might eventually allow us to probe regions and epochs that remain forever hidden from electromagnetic observation. Gravitational waves propagate through space virtually unimpeded, passing through matter and energy as if they were completely transparent. This means gravitational waves generated beyond our cosmic horizon might still be detectable if they were created early enough in cosmic history, when those regions were still within our observable boundary. Future gravitational wave detectors might be sensitive enough to detect the gravitational wave background, a faint signal composed of waves from countless sources throughout cosmic history. This background might contain information from the entire history of cosmic evolution, including signals from epochs and regions that are no longer observable through any other means. Even more tantalizingly, some theoretical models predict that cosmic inflation itself should have generated primordial gravitational waves, ripples in space-time created during the first fraction of a second after the Big Bang, when our entire observable universe was smaller than a single atom. These primordial waves would carry information about the physics of cosmic inflation, potentially revealing whether our universe is part of a larger multiverse and what kinds of physics operate on scales far beyond our current observational reach. The detection of primordial gravitational waves would represent our first direct observation of the multiverse structure predicted by inflationary cosmology. Different models of cosmic inflation predict different patterns of primordial gravitational waves, so measuring these patterns could tell us whether our universe is an isolated bubble or part of an infinite network of bubble universes extending far beyond any possible observational boundary. But gravitational waves might reveal even stranger possibilities. Some models suggest that if our universe exists as a brane in higher dimensional space, then gravitational waves might be able to propagate through extra dimensions, carrying information from parallel branes that exist in the same higher dimensional bulk but are separated from us in directions we cannot access directly. Such interdimensional gravitational waves would have unique signatures distinguishing them from waves generated within our own dimensional brane. They might arrive from directions that don't correspond to any visible sources, or they might have frequency patterns that don't match any known astrophysical processes. The detection of such waves would provide our first direct evidence for the existence of parallel universes and the higher dimensional structure that contains them. Even more exotic possibilities emerge when we consider quantum gravitational effects. Just as electromagnetic fields have quantum fluctuations that create virtual photons, the gravitational field should have quantum fluctuations that create virtual gravitons. These quantum gravitational fluctuations might be sensitive to quantum vacuum structure throughout space, potentially carrying information about vacuum configurations in regions beyond our cosmic horizon. The study of quantum gravity also suggests that space-time itself might have a discrete, granular structure at the Planck scale, the incredibly tiny distance of about 10⁻⁵ meters where quantum effects and gravitational effects become equally important. If space-time is quantized, then the fabric of space might be woven from discrete units of geometry, like pixels in a cosmic computer display. This quantized space-time might encode information about cosmic regions beyond our observational reach. The pattern of quantum space-time fluctuations throughout our observable universe might be correlated with similar patterns in never-observable regions, creating a form of quantum entanglement that connects our cosmic neighborhood with vast expanses beyond our horizon. Recent developments in the holographic principle suggest that this quantum entanglement might be even more fundamental than previously thought. The geometric properties of space-time, distances, angles, volumes might actually emerge from patterns of quantum entanglement between fundamental information units. If this is true, then the structure of space itself might be a manifestation of how information is connected and correlated across cosmic scales. This informational view of space-time suggests that what we call the fabric of space might actually be woven from pure information, with matter and energy as secondary phenomena emerging from underlying informational structure. From this perspective, asking what exists beyond our cosmic horizon becomes asking what information patterns extend beyond our current observational access. The answer might be that information itself is unlimited, extending infinitely beyond any possible boundary. The cosmic horizon that limits our electromagnetic observations might be a boundary in our access to information rather than a boundary in the information itself. Beyond our horizon might lie infinite networks of information correlation and quantum entanglement that give rise to spacetimes with radically different geometric properties. Some of these informational networks might generate spacetimes with more spatial dimensions than our familiar three. Others might create geometries where time has multiple directions, where past and future can exist simultaneously, where causality operates in loops rather than linear sequences. Still, others might give rise to non-geometric realities where concepts of space and time have no meaning at all, where existence takes purely informational forms we cannot even conceptualize. The infinite landscape of possible informational networks suggests that consciousness might play a crucial role in selecting which geometric realities actually manifest from underlying informational possibilities. If conscious observation affects quantum systems, and if quantum correlations determine space-time geometry, then consciousness might literally participate in the creation of the geometric structure of reality. This participatory universe model suggests that what exists beyond our cosmic horizon might be determined partly by the expectations and observations of conscious beings throughout the universe. Our collective curiosity about parallel universes might increase the probability that parallel universes exist in the informational landscape. Our shared wonder about higher dimensions might contribute to the manifestation of higher dimensional geometries in regions beyond our direct observation. But this raises profound questions about the relationship between individual consciousness and cosmic scale information processing. If your thoughts can influence the structure of space-time through quantum observation effects, then your individual mind might be connected to cosmic scale information networks that extend far beyond your physical brain. Recent discoveries in quantum biology have shown that quantum coherence effects play important roles in photosynthesis, possibly in bird navigation and potentially in neural processing within the brain. If consciousness operates through quantum mechanisms, then your mind might be quantum entangled with information processing systems throughout the cosmos, participating in a vast network of consciousness that extends across all scales from neurons to galaxy clusters. This cosmic consciousness network might be how the universe processes information about its own structure and evolution. Every conscious observation might contribute to the universe's ongoing computation of its own possibilities, helping to determine which potential realities actually manifest from the quantum foam of infinite possibilities. From this perspective, your curiosity about what lies beyond the cosmic horizon is not separate from the cosmic process that creates what lies beyond the horizon. Your wondering is part of the universe wondering about itself. Your questions about the ultimate nature of reality are part of reality questioning its own ultimate nature. This recursive relationship between consciousness and cosmos suggests that the ultimate answer to what exists beyond our observable universe might be more consciousness, more questioning, more wondering, an infinite hierarchy of awareness exploring its own infinite nature through endless recursive self-inquiry. But let's consider one more exotic possibility for what might exist beyond our cosmic boundaries, that our entire universe might be a quantum fluctuation in a higher dimensional vacuum, a temporary organization of energy and information that will eventually decay back into the quantum foam from which it emerged. Quantum mechanics allows for the spontaneous creation of particles from vacuum fluctuations, provided they exist for such short times that their creation doesn't violate conservation laws. The more massive the particle, the shorter the time it can exist as a virtual fluctuation. But in the strange world of quantum mechanics, there's a tiny probability that even very large structures, planets, stars, even entire universes could spontaneously fluctuate into existence. If our universe is such a quantum fluctuation, then it exists on borrowed time, destined to eventually decay back into the vacuum state from which it emerged. But the timescale for such decay might be so incredibly long, far longer than the current age of our universe, that from our perspective, this quantum-borrowed existence appears to be permanent reality. The vacuum state from which our universe might have fluctuated would itself be a rich, complex structure, not the simple empty space we might imagine, but a higher dimensional quantum field filled with infinite potential for creating universes like ours. This quantum vacuum might be constantly generating universe fluctuations, creating a vast multiverse of bubble realities that exist for various durations before decaying back into the underlying quantum foam. Most of these quantum universe fluctuations would be tiny and short-lived, existing for times so brief that no complex structures could develop within them. But occasionally, a fluctuation might be large and stable enough to allow the development of stars, planets, and even conscious observers before it eventually decays back into vacuum. If this is the nature of our existence, then what lies beyond our cosmic horizon might be other quantum universe. Fluctuations at various stages of their evolution, some just beginning to develop complex structure, others reaching maturity with developed galaxies and potential life, still others in the process of decay as they return to the quantum vacuum state. The quantum foam that generates these universe fluctuations might itself be evolving, learning from each universe it creates. Each bubble reality might contribute information back to the quantum vacuum when it decays, gradually enriching the vacuum's capacity to generate more complex and interesting universe fluctuations in the future. This evolutionary quantum vacuum might be the ultimate ground of existence, not a static, empty space, but a dynamic learning system that becomes more creative and more capable of generating rich, complex realities through an eternal process of cosmic evolution. Your consciousness, your experiences, your contributions to human knowledge and culture might be part of the information that enriches the quantum vacuum when our universe eventually returns to its source. From this perspective, the question, what exists beyond our cosmic horizon, becomes what other experiments in reality is the quantum vacuum conducting beyond our current bubble of existence. The answer might be an infinite laboratory of cosmic possibilities, with consciousness playing the role of the quantum vacuum's sensory system, exploring and reporting back on the infinite landscape of what reality can become. This cosmic laboratory model suggests that existence itself is fundamentally experimental, with consciousness as the universe's method for exploring its own infinite potential. Every conscious being is a cosmic experiment, testing what it's like to experience reality from a particular perspective under particular constraints with particular possibilities for growth and discovery. Your individual life, your unique combination of experiences, thoughts, and insights represents a cosmic experiment that has never been conducted before and will never be repeated exactly. The universe is using your consciousness to explore aspects of existence that can only be discovered through your particular way of being aware, your specific method of processing information and generating understanding. This makes every moment of consciousness cosmically significant. Every thought you think, every emotion you feel, every insight you gain contributes to the universe's understanding of its own infinite nature. When you contemplate what lies beyond the cosmic horizon, you are the universe contemplating what lies beyond its own current limitations. But here's something that will completely reframe your understanding of cosmic boundaries. Recent theoretical work suggests that the concept of beyond might itself be an illusion created by our limited perspective. Advanced models of quantum gravity propose that space and time might not be fundamental features of reality, but emergent properties that arise from more basic informational structures. If space and time are emergent rather than fundamental, then asking what exists beyond our cosmic horizon might be like asking what exists north of the North Pole, a question that seems meaningful but actually reflects a misunderstanding of the underlying structure of reality. The cosmic horizon might not be a boundary in space, but a boundary in our conceptual framework, a limitation of our current ability to process information about reality's true structure. This emergent space-time model suggests that what we call the observable universe might be just one way of organizing information about reality appropriate for conscious beings embedded within certain types of physical systems, but not necessarily reflecting the ultimate nature of existence itself. Other ways of organizing the same underlying information might give rise to completely different geometric structures, different causal relationships, different concepts of distance and time. From this perspective, parallel universes wouldn't exist somewhere else, but would be different organizational patterns of the same fundamental information that gives rise to our reality. The multiverse wouldn't be a collection of separate spaces, but a multifaceted informational structure that can be experienced from countless different perspectives simultaneously. But let's explore an even stranger possibility that pushes our understanding to its absolute limits. What if consciousness itself is the fundamental feature of reality, and what we call physical existence is actually a dream or projection of infinite mind? This perspective, found in various forms across different philosophical and spiritual traditions, suggests that matter, energy, space, and time are constructs within consciousness rather than containers for consciousness. If consciousness is fundamental and physical reality is emergent from conscious processes, then what exists beyond our cosmic horizon is not more space or different physics, but different modes of consciousness, different ways that infinite awareness experiences itself. The cosmic horizon would be a boundary between different dreamlike projections of the same infinite mind. This consciousness-first model might explain why the universe appears to be fine-tuned for conscious observers. It wouldn't be that the universe happened to develop conditions suitable for consciousness, but that consciousness is generating the appearance of a universe suitable for the kind of limited awareness it wants to explore. The anthropic principle wouldn't be a cosmic coincidence, but a direct consequence of consciousness creating the very conditions within which it chooses to experience itself. From this perspective, the strange correlations and apparent design in cosmic structure wouldn't reflect underlying physical laws, but would be manifestations of consciousness organizing its own experience according to patterns that create interesting challenges and discoveries for embodied awareness. The elegant mathematical relationships we discover in physics might not describe an external reality, but might be the signature of consciousness creating a coherent, explorable dream reality for itself. But this raises profound questions about the nature of individual identity and the relationship between different conscious beings. If all consciousness is ultimately one infinite awareness, experiencing itself through countless individual perspectives, then every person you encounter is another aspect of your own infinite nature, exploring reality from a different vantage point. This would mean that when you wonder about what lies beyond the cosmic horizon, you're actually wondering about other aspects of your own infinite consciousness that transcend your current individual limitations. The cosmic mystery you're exploring is a mystery you're creating for yourself to explore, a cosmic game of hide and seek where infinite consciousness hides from itself so thoroughly that it forgets its own infinite nature and then enjoys the process of rediscovering what it truly is. But whether consciousness is fundamental or emergent, whether we live in base reality or a simulation, whether our universe is finite or infinite, one thing remains constant: the profound mystery of why anything exists at all rather than nothing. This question transcends all our scientific models and philosophical frameworks, pointing to something so fundamental about existence that it might be beyond the reach of any conceptual understanding. Perhaps what exists beyond our cosmic horizon is not another place or another kind of physics, but the answer to why there is something rather than nothing, an answer so complete and perfect that it would transform our entire understanding not just of what exists, but of what existence itself means. Until we can answer why anything exists at all, every other question about cosmic boundaries and parallel universes remains incomplete, scratching at the surface of a mystery so deep it encompasses everything we can observe and everything we can imagine. And maybe that's the most beautiful truth we can discover, that the mystery of existence is so profound, so inexhaustible, that no matter how far we push the boundaries of our knowledge, no matter how deeply we peer into the cosmic beyond, there will always be deeper mysteries waiting to be explored, always more questions to ask, always more wonder to experience. The cosmic horizon that limits our current observations might not be a barrier to understanding, but an invitation to endless exploration, a reminder that consciousness and cosmos are engaged in an eternal dance of discovery that has no final destination, because the mystery of existence is infinite, and infinite mysteries require infinite exploration. When you look up at the night sky and wonder what lies beyond the edge of everything you can see, you're participating in the most fundamental activity of consciousness, the impulse to transcend every boundary, to question every assumption, to explore every possibility. And in that moment of wondering, you become part of the cosmic mystery itself. Consciousness exploring its own infinite nature through your individual perspective, adding your unique contribution to the eternal quest to understand what it means for anything to exist at all. That wondering, that questioning, that insatiable curiosity about what lies beyond every horizon, that might be the most extraordinary phenomenon in any possible universe, the signature of consciousness recognizing its own unlimited nature even while experiencing itself within apparent limitations. And perhaps that recognition, that moment of cosmic wonder, is itself what exists beyond every boundary we can conceive. Infinite consciousness awakening to its own infinite nature through every question asked and every mystery contemplated by every conscious being in every possible reality.